Hello guys, welcome back. This is the second lecture of the series Electrical for Gate and IES in 10 minutes. In this lecture we are going to solve some numericals related to electrical circuits. In the first lecture we discussed about important formulas and concepts related to electrical circuits which are asked in Gate and IES exams. If you haven't watched that video, you can just go and watch that to brush up the important concepts related to electrical circuits. So this is all about me. I have done BTech from BIT Misra and MTech and PhD from IIT Kharagpur. I have cleared GATE and Indian Engineering Services exams. This is the first numerical which we are going to solve today. In this electrical circuit, we have to find the value of resistance R. There are different methods to solve this particular problem. We are going to solve it through superposition principle to demonstrate the effectiveness of this theorem. Hint is that whenever there are two or more sources in a circuit, we can think about using superposition principle. In superposition principle, we remove one source, either voltage or current, then solve for circuit equations. Then we remove other source and solve for circuit equations, compare those equations and we get the result. In this particular problem, we will first remove the 2 ampere source and solve for current in the branch with 12 ohm resistance. Then we will remove the 6 volt source and again solve for current in the branch with 12 ohm resistance. Then adding these two currents, that will be equal to 1 ampere. So, and solving that, we will get the value of R. Now, when we remove the 2 ampere source, the resultant circuit will be like this. This is because current source has infinite resistance or impedance, so this branch will be open circuited. So this is the resultant circuit, and we solve for I1. I1 will be 6 divided by 12 plus R. Now we remove the voltage source and connect the 2 ampere source back. When we remove the voltage source, the resistance of a voltage source is 0, so it will be simply short circuited. The resultant circuit will be like this, and we solve for I2. I2 will be 2 into R divided by 12 plus R. The simplification of I2 is given here. You can remember in short trick that whenever there are two branches in parallel, then the current in second branch is equal to the product of total current and the resistance in first branch and divided by the sum of the two resistances. This trick will be very useful in solving many numericals. Now we compare both the currents I1 plus I2, that will be equal to 1 ampere, it is given. And on solving this, we will get the value of resistance R equal to 6 ohm. So we have found the value of resistance R which was asked. If you have any doubts regarding this numerical, please ask in the comments and I will try to solve it. This numerical can also be solved by a short trick. Here the current in 12 ohm resistance is 1 ampere, so total potential drop across this branch is 12 volts. Now total current is 2 ampere. 1 ampere is flowing in the 12 ohm resistance, so the current in resistance R branch will be equal to 1 ampere. Now solving this network equation, that will be 12 volt is equal to current I into resistance R plus 6 volt. So resistance R will be 6 ohm. So this is the short method. These methods will be clear to you as you practice more and more numericals. You will be able to apply these at your own. This is the second numerical which we are going to solve today. In this circuit, input capacitance has been asked. So इस न्यूमेरिकल के साइज को देख के डरने की ज़रूरत नहीं है, ये बहुत ही सिंपल न्यूमेरिकल है. We will just see its solution. Now we know that the total potential drop is equal to the potential drop across resistance plus potential drop across capacitance. Now the potential drop across capacitance, that can be found from this formula. Q is equal to Vc, and Q is also equal to integral of I dt. So the potential drop across capacitance will be 1 by C integral I dt. So potential drop V is equal to IR plus 1 by C integral I dt. We will be using this concept. Now writing the branch equation for the circuit, V1 is equal to I1 into R is equal to 2 into 10 raised to power 3. Adding the two resistances of 1 kilovolt, 1 kilo ohm, 1 kilo ohm, which are in series, plus the potential difference across the capacitance, that is equal to 1 by C integral I dt. Now the capacitance is 100 microfarad, millifarad, and the total current is I1 plus 49 I1, as you can see from the circuit. So the total current will be 50 I1. So 1 by C integral 50 I1 dt. Now suppose the capacitance of the input loop is CEQ, equivalent capacitance. So writing the equations again for the input loop, V1 will be equal to 2 into 10 raised to power 3 I1 plus 1 by CEQ integral I dt, I1 dt. This is for the input loop. Now comparing these two equations, capacitance, equivalent capacitance will be equal to C1 by 50, that will be equal to 2 microfarad. So if you have any doubt regarding this numerical, please ask in the comments and I will try to answer it. Now this is the next numerical. In this circuit shown, we have to find the value of current I. We can clearly see there are two loops, so it is easy to apply Kirchhoff's loop equations in this numerical. We consider first loop and we apply Kirchhoff's voltage law to this loop. With current I1, we will get 5 is equal to I1 into 2, 1 plus 1 ohm resistance, that will be 2. So I1 will be equal to 2.5 ampere, and the voltage VA, that will be equal to IR, that will be 2.5 volt. Now we apply KVL to the loop 2. In the loop 2 we will have 4 VAB is equal to 3 plus 1 into I, because the voltage source is given to be 4 VAB and the total resistance of the loop will be 3 plus 1 ohm, that will be 4 ohm. So 3 plus 1, so VAB will be equal to I. Now the voltage at point B will be equal to I into R. Now the current I is I only, as given in the question, and the resistance is 1. So VB will be equal to I. Now the voltage potential drop V across the branch AB, VAB, will be equal to VA minus VB, that is equal to I, and on solving this we will get the value of I equal to 1.25 ampere. So this numerical is solved. If you have any doubt, please ask in the comments. Now we move on to the next numerical. In this numerical, a 3 volt DC supply with an internal resistance of 2 ohms supplies a passive non-linear resistance characterized by the relation VNL is equal to I square NL. Find the power dissipated in the non-linear resistance. First we will make the circuit as given in the problem. So a 3 volt DC supply is with an internal resistance of 2 ohm. So 3 volt in series with 2 ohm, and a non-linear resistance is connected across it. So VNL is connected across it. VNL is the voltage dissipated in this non-linear resistance, and that is equal to I square NL. Now writing the network circuit equations, that will be 3 minus VNL, the 3 volt source here, and the potential drop across the non-linear resistance, that is VNL. So 3 minus VNL, that is equal to 2, the resistance which is 2, and multiplied by the current INL. From here we will get VNL is equal to 3 minus 2 INL. Also VNL is equal to I square NL, it is given. Now comparing these two equations with VNL, We will solve and get INL. INL comes out to be -3 or 1, but as the load is passive, it cannot supply current, so INL cannot be equal to -3 ampere. So INL is 1 ampere. Now VNL is equal to I square NL, so VNL will be 1, and power dissipated will be equal to the product of voltage into current, that will also come out to be equal to 1. So this numerical is solved. If you have any doubt related to it, please ask in the comments. Thank you.